Okay, good morning, class. So today what I'm going to talk you through, and this is my first created video for you guys, is how to graph a logarithmic function. Now, one thing I never said to you, because I haven't been with you, is that exponential functions and logarithmic functions are inverses of each other. So we use that fact to graph a logarithmic function without a calculator. So keeping that in mind, I thought the first thing we do is talk about the graphs of exponential functions. And then after we review that, we will again revisit the fact that exponential functions and logarithmic functions are inverses of each other. And then we'll look at the logarithmic functions graph. And basically, we use that fact to graph a logarithmic function. So, very important to remember that exponentials and logarithmic functions are inverses of each other. Okay? So, first thing to keep in mind, we will talk about exponential functions. And when we've graphed without a calculator, the first thing we've always done is graph the parent and then transformed it. So exponential functions, there is no one specific parent. There are multiple parent exponential functions, and that's why I'll put that in quotations. There's not one true function. So we could be looking at y equals 2 to the x. That's in the form of a parent exponential because it's very basic. It just is a number raised to the x power and nothing else. We could also have y equals 3 to the x, y equals 10 to the x. These are all forms of parent exponential functions. If they had transformations, if they weren't a parent, they'd have something in the HK spot. So if we remember, we could have something y equals 2 to the x minus h plus k. And that would be taking on a transformed exponential. But right now, we're just going to focus on the parent because we use parent exponentials to help us graph the logarithmic functions. Okay? And we'll talk later about transforming a log function. So anyway, these three are forms of parent exponential functions. Now, when we're graphing an exponential, specifically a parent exponential, we create our table, and the best points to graph with an exponential function, the best x values are -1, 0, and 1. Let's say we're graphing y equals 3 to the x. When I put a -1 in for x, I would get out a 1/3. When I put a 0 in for x, anything to the 0 power is 1. And when I put a 1 in for x, I get itself out. And if you remember, actually, we didn't talk about this together, but if I wanted to look at a parent exponentials table using notation, a parent exponential would be of the form y equals b to the x. So when I choose these three great x values for exponential functions, when I put a -1 in, I get 1 over b. When I put a 0 in, I still get a 1 out. And when I put a 1 in, I get b. So something to keep in mind is this point 0, 1 is on every parent exponential graph. We're guaranteed that. And that's because anything to the 0 power is 1. So I'm going to go ahead and graph this parent exponential. So when x is -1, y is 1/3. When x is 0, y is 1. And when x is 1, y is 3. Now we just studied exponential functions. So I know the domain of any exponential function is all real numbers, which we could say the double R, or negative infinity to positive infinity. And the range of this exponential function is bounded by the asymptote, which in this case is y equals 0. So our range would be y is greater than 0 or 0 to infinity in notation. So this is the graph of a parent exponential function. And what we're going to do now is talk about properties of logarithmic functions, and then we'll go through an example of graphing a parent log that is the inverse of this parent exponential.